Hello all, welcome to Narayana IAS Academy. This is Prashant. So as part of our CSAT lectures, yesterday we had the CSAT orientation lecture. So in which we discussed all about the CSAT paper and what is the significance of CSAT, and also we have seen the given syllabus and the derived syllabus and exam pattern all from the UPSC notification, and also we have seen the PYQ trend analysis in order to identify the topics which have highest weightage in the exam. And also we discussed about the strategy to approach this CSAT paper and the strategy to score 100 plus marks in this paper. So today I will be starting with the number system topic. So the number system topic belongs to this quantitative aptitude or maths component of the syllabus, and this is one of the topic which have highest weightage in the exam considering the PYQ trends. So let's start with the topic and be attentive. So what are numbers basically? So what are numbers? So numbers are mathematical symbols which are used to count, measure or label any objects. For example, if you want to count how many people are sitting in the classroom, so you need something for that. So you need numbers. 10 people are sitting, 10 is a number. If you want to measure the distance from point A to point B, so you need something, 10 meters, so 10 is a number. And if you want to measure the weight, so on the bigger scale, if you see, if you want to measure the economic growth of Indian economy, so economic, how Indian economy is performing, so for that you need numbers. So numbers are basically mathematical symbols which are used to count, measure or label objects. So the first one, if you see, the classification of numbers. So we will see these numbers are can be classified into many number of types. So the first and most important one is the natural numbers. So what are natural numbers? So natural numbers are the normal numbers that we use in our everyday life to count things and all. So these are also called as counting numbers. So these are also called as counting numbers. So humans were using these numbers since prehistoric times, and that's why they are called as natural numbers. So these numbers starts from 1, 2, 3, 4 and so on. So this is the first category of numbers in the classification. The next one is whole numbers. These are nothing but if you add 0 to the natural numbers, you will get the whole numbers. So including 0, so whole number starts from 0, 1, 2, 3 and so on. So if you add 0 to the natural numbers, you will get whole numbers. The next set of numbers is integers. These are nothing but for every single number there is a negative counterpart. So that is natural numbers are 1, 2, 3, 4, 5, 6 and so on. The negative counterparts of these numbers is -1, -2, -3, -4 and -5. So what are basically negative numbers? What is the meaning of a negative number? If you want to measure the distance of an object, you need a positive number. In the similar fashion, if suppose I want to tell the temperature of Siberia, which is below 0 degrees centigrade, so there you need negative numbers. So if you combine all the positive numbers, 0 and negative numbers, you will get integers. So integers include all the negative numbers, all the positive numbers and 0. So these are integers. The next set of numbers is rational numbers. What are rational numbers? So rational, the word comes from the word ratio. So these are those numbers which can be expressed in the form of a fraction. For example, there is a number which can be expressed in the form of a fraction p by q, but the denominator should not be equal to 0. So in a fraction, this is called numerator and this is called denominator. So any number that can be expressed in the form of a fraction is called rational number. So for example, 1 by 2, 3 by 4 or else 9 by 13. So these numbers are rational numbers. And one more important thing is, if suppose I want to write in this decimal form, so 0.5, 1 by 2 is 0.5 and 3 by 4 is so 0.75. So this is one of the most important thing of these rational numbers is the decimals should be terminating or repeating decimals. So terminating decimal, 1 minute. So rational numbers are any numbers, they can be expressed in the form of fraction. For example, if you take 1 by 2, 3 by 4, and also one important thing is the decimal form. In the decimal form of these fractional numbers, they should be terminating or repeating. So if you convert this 1 by 2 into decimal form, it will be 0.5. So after 0.5, the number is ending. So this is called terminating decimal. So it is, so for a number to be rational number, it must be either terminating decimal or repeating decimal. For example, if you take 1 by 3, so what is 1 by 3? If you convert into decimal form, 0.3333. It's a non-terminating decimal, however it is a repeating decimal, so 0.33333, so it is a repeating decimal. So 1 by 3 is also a rational number. So this is next, the next set of numbers are irrational numbers. So the meaning is in the word itself. What is irrational numbers? These are those numbers which cannot be expressed in the form of a fraction. For example, if you take root 2, the value of root 2 is 1.4143 something and all. It goes on. So it is a non-terminating and non-repeating decimal. So this is non-terminating and non-repeating decimal. So these numbers are called as irrational numbers. For example, root 3 and pi is also a irrational number. It is a non-repeating and non-terminating decimal. So these are called irrational numbers. Now if you combine these rational numbers with irrational numbers, the larger set is called real numbers. So if you combine rational numbers and irrational numbers, they are called as real numbers. Now the last set of numbers, they are called as imaginary numbers. What are these imaginary numbers? These are basically square roots of negative numbers. For example, if you take the square root of -1, square root of -5, square root of -11. So these are called imaginary numbers. And these are usually denoted with the symbol. The root -1 is denoted with I. So root -5 is expressed as 5i. This is expressed as 11i. So these are imaginary numbers. Now the larger subset, that is called complex numbers. These are nothing but the combination of real numbers and imaginary numbers. And usually these are expressed in the form of a plus ib. And this a is the real part, this ib is the imaginary part. So you can see the examples: 3 minus 4i, 7 plus 2i, root 3 minus 5i. So this is called the real part and this is called the imaginary part. So these are called complex numbers. So this is the broad classification of numbers. So starting with the natural numbers, these are nothing but nothing, also called as counting numbers. We use in everyday life to count. So these starts from 1, 2, 3, 4 and all. If you add 0 to the natural numbers, you will get whole numbers. And the whole numbers, if you add the negative counterparts, you will get the integers. Next set of numbers is rational numbers. They are nothing but ratio, that means fraction. These numbers can be expressed in the form of fraction, and two important conditions are they should be terminating decimal or else repeating decimal. The next set is irrational numbers. These are those numbers which cannot be expressed in the fraction form. For example, root 2, root 3, root 5, these are all irrational numbers. Now, if you combine these rational and irrational numbers, you will get the real numbers. Now, the next set of numbers is imaginary numbers. These are basically square roots of negative numbers. Root minus 1, root minus 5, root minus 11. These are all imaginary numbers. Now, if you combine the real number with the imaginary number, you will get the complex numbers. They are usually expressed in the form of a plus ib, where a is the real part, ib is the imaginary part. So this is the broad classification of numbers. Now we will discuss even and odd numbers. Even and odd numbers. What are even numbers? Even numbers are those numbers which are divisible by 2. What is being divisible by 2? So if you divide any particular number with 2, the remainder will be 0. For example, there is a number 4. If you divide it with 2, 2 2s are 4, the remainder is 0. So if any number that is divisible by 2, it is called even number. So for example, 4, 6, 8, 10, 12 and so on. So these are even numbers. The next set of numbers are odd numbers. These are those numbers which are not divisible by 2. For example, if you take 3, so if you divide it with 2, 2 ones are 2, 1 is the remainder. So if you do not get the 0 remainder when you divide a particular number with 2, that is odd number. So what are the examples of odd numbers? 3, 5, 7, 9, 11 and so on. So these are the even numbers and odd numbers. So even numbers are those numbers which are divisible by 2. Odd numbers are those numbers which are not divisible by 2. Now we will discuss there are some important properties of even and odd numbers, and these properties are very useful in solving the sums. So you can see these are the important properties of even and odd numbers. So if you add a even number and even number, you will get even number. For example, if you add 2 plus 4, so you will get 6, that is again even number. The next property is if you add odd number to another odd number, you are getting even number. For example, if you add 1 plus 3, so you are getting 4. So odd plus odd is equals to even number. Next, odd. If you multiply an odd number with an odd number, you are again getting odd. For example, 3 into 9, that is 27. This is again odd number. Next, if you multiply an odd number with even number, you are getting even number. Take an example of 3 into 2, you are getting 6. That is even number. Next property is even into even. You are again getting even number. For example, 2 into 6, you are getting 12. So it is again even number. These are the properties. Next three properties are even to the power odd number. For example, 2 cube. So 2 is the even number, 3 is the odd number. So you are again getting 8. That is even number. Next property, odd to the power even. For example, 3 square. You are getting 9. So that is odd number. Next property is even to the power even, that is 2 to the power 4. For example, you are getting 16. So this is even number. The last property is odd to the power odd. So that is nothing but 3 to the power 3. So you will get 27, that is odd number. And these properties are very useful in solving the sums. These are like shortcuts, so you don't need to do the calculation and all. If you remember these properties, it will save time while solving problems. So what are those properties? Even plus even is even number. Odd plus odd, again you will get even. Odd into odd, so if you multiply an odd number with another odd number, you will again get odd number. Odd into even is even. Next, even into even is even number. Even to the power odd, that is again you are getting even. Odd to the power even, you are getting odd number. Even to the power even, you are getting even. Odd to the power odd, you are getting odd number. Note down these properties, these are very important while solving problems. So let me show you an example. So you can see the problem. There are two-digit numbers which are AB and CD. Next, BA is the another two-digit number prepared by reversing the digits of AB. So there are two numbers AB and CD. Now BA is the reversal of AB. Now they have given one condition. If AB into CD is 493 and BA into CD is 2059, what is the value? Z, that is the sum of AB plus CD. Try to solve it. And this problem can be solved using the properties of even and odd numbers. So take some time, try to solve the problem. Okay, let me solve it for you. So the condition given is AB into CD is 493. So 493 is an odd number. When you will get an odd number in multiplication? When you multiply odd number with another odd number. So AB is an odd number, CD is an odd number, right? Next, BA into CD is 2059. Here also the 2059 is an odd number. When you will get an odd number in multiplication? If you multiply odd number with an odd number again. So all these are A, B, C, D, B, A are odd numbers. Now what is the sum of AB plus CD? AB is an odd number, CD is an odd number. If you add odd number with another odd number, you will get even number. So the answer must be an even number. Check the options. 43 odd, 50 odd, 47 odd, 46 is the even. So directly checking the options, you will get the answer. So the answer will be 46, option D. So this is the way you should use these properties of even and odd numbers to solve the problems. Let me show you another example. So the question reads, I have multiple gift vouchers of value 101, 107, 111, 121, 131, 141, 151, 171. So these are all the values of gift vouchers. I have to pick exactly 10 vouchers to make a payment of 1121. In how many ways I can do that? Try to read the question, understand, try to solve it. Okay. So what is the question? we have multiple gift vouchers. So we have gift vouchers. They are of value 101, 107, 111, 121, 131, 141, 151, 171. So if you observe, all these are odd numbers. So all the gift vouchers are of value which are odd numbers. Now we have to make the payment of 1121. So you have to use these vouchers only. So you have to use these vouchers. If you add any of the two odd numbers, what you will get? Even number. So odd plus odd is equals to even number. So if you try to make payment with these vouchers, you can make only payment of an even value. So 1121 is not possible. So the answer will be none of these. So this is how you should use the properties of even and odd numbers. So they have given the vouchers which are all odd numbers, and you have to make the payment which is again an odd number. If you add an odd number with an odd number, you will get only even number. So the answer will be none of these. See this question. So this question was asked in CSAT 2023 paper. So the question reads, 3 of the 5 positive integers. So there are 5 positive integers P, Q, R, S, T, and 3 of them are even numbers and 2 of them are odd numbers, not necessarily in the same order. So consider the following statements. P plus Q plus R minus S minus T is definitely even. The second statement reads 2P plus Q plus 2R minus 2S plus T is definitely odd. Now they are asking which of the above statements is are correct. One only, two only, both 1 and 2, neither one nor 2. So this is a moderate question. You have to use the properties of even and odd numbers. Take time, try to solve it. Okay, let me try this. So there are 5 positive integers. They are P, Q, R, S, T, and 3 of them are even numbers. 2 of them are odd numbers, but they are not necessarily in the same order. So there are 5 positive integers P, Q, R, S, T, and 3 of them even numbers and 2 of them are odd numbers. So this is the conditions given in the question. Now they are asking P plus Q plus R minus S minus T is definitely even. So definitely means there is no possibility, it must be even number. So it is the question. So it can be expressed as P plus Q plus R minus T. If you take minus common, you can write it like this. Now if you take S and T, so these are the two numbers. What are all the possibilities for S and T? S can be an odd number, T also can be an odd number, and the next possibility can be S can be an even number, T also can be an even number. What can be the next possibility? This can be odd number and this can be even number. And what is the other possibility? This can be even number, that can be odd number. But these are the three. So these are almost same. This is odd, that is even, this is even, that is odd. So that is same condition only. So we have three possibilities for S and T. So one is both are odd numbers, both are even numbers, and one is odd number and one is even number. So if you see S plus T, in the first case what will happen? S plus T. So both, if you are adding two odd numbers, you are getting even number. Okay. Now P plus Q plus R minus S plus T. See, the S plus T is an even number because you are adding odd number and odd number. Now the two odd numbers are involved here. Now all these will be even numbers only. Because the total in total there are three even numbers and two odd numbers. If S and T both are odd numbers, what is the possibility? All the P, Q, Y, R should be even numbers. And you are again adding 3 even numbers. So you will get even. Minus S plus T is even. So what will be the result? Even number. So if you take the first possibility, you are getting P plus Q plus R minus S plus T is even number. Okay, it is satisfying this statement. But also take the second possibility. What is that possibility? Even and even. So what will be S plus T? Even plus even is equals to even number. Now see, if S plus T is even and even, what are the possibilities for P plus Q plus R? There are 3 even numbers. So 2 are already here. So there will be one even number plus odd number plus odd number. So what is odd plus even? Odd plus odd is even plus even is again even. So even minus, this is what? Even plus even is equals to even, that is again an even number. So even in the second possibility, that statement is satisfying. Now see the third possibility, odd plus even. What is odd plus even? 2 plus 3, 5. So S plus T will be odd number. Now in the S and T there is one odd number and one even number. So in P, Q, R, what will happen? Already one odd number is used. So there will be one odd number and one even is used. So there will be two even numbers. Right? So even plus odd. Even plus even is even plus odd is odd. So this will be odd number minus, this is again odd number. So that will be even number. Sorry, odd minus odd. For example, 7 minus 3, that is 4, even number. So observed, in all the possibilities, you are getting this as even number. So that's what the statement 1 is. P plus Q plus R minus S minus T is definitely even. So in all the possibilities, the answer is even number. So the statement 1 is correct. Statement 1 is correct. Now see the second statement. See the second statement. 2p plus q plus 2r minus 2s plus t. So this is nothing but 2p plus q plus 2r minus 2s plus t. So take all the 2 common, that is 2 into p plus, so there are 2p, 2r, 2s. So that is nothing but p plus r minus s, and this will be q plus t. So the expression can be written like this. Now if you see, you are multiplying some number. So p plus r minus s. It can be even or odd, but you are multiplying with 2. So if you multiply even number, for example 2 into 2, you will get even number. Even if you multiply an odd number with 2, you will get an even number. 3 2s are 6. So all this expression must be even number. So one thing is fixed. Now let's go for the another expression, that is q plus t. So what are the possibilities for q and t? Again in the similar fashion we have seen earlier, odd, odd, even, even, odd, even. So these are the 3 possibilities. Now what will be the value of q plus t? Odd plus odd, even plus even, again even, odd plus even, that is odd. Okay, so the first expression is always even because we are multiplying with 2. Now the second expression, there are 3 possibilities. One is e, one is odd number, and again another is e. So same only. Now if you add even plus even, you will get even. If you add even and odd, you will get odd number. So the answers are 2 possibilities, that is even and odd. Now what the statement is statement reads, 2p plus q plus 2r minus 2s plus t is definitely odd. So this is a wrong statement. So the statement should be like, this can be odd. Can. So can indicates possibility. Here they are saying it is definitely odd, but we are getting two possibilities. It can be even number, it can be odd number. So the statement 2 is wrong. So the answer will be 1 only. So this is how you should solve this question. So in this question we are using only the properties of even and odd numbers. That's why they are very important. Let me show you another approach to this question. Okay, we can do all the possibilities and all. We have to understand all the possibilities. This is a kind of lengthy process. The same question you can do it using just example approach. So take some examples and directly check for the options. For example, they are saying there are 5 integers p, q, r and st. 3 are even numbers. So 3 are even numbers and 2 are odd numbers. So you can take for example 1 and 3. These are odd, and 2, 4, 6. So you can take examples. So here you have taken 5 positive integers which are 3 even numbers and 2 odd numbers. So you can do it like that. P plus q plus r minus s is definitely even and all. So you can substitute this one. You have to take any other options. So to check, directly checking through the options. So this is one of the approach that helps in solving the questions quicker. So in this the answer is neither one nor two. So try with this approach and try to understand, but in that possibility approach and all, that applies to any question. Next, one more question. Again, the application of the properties of even and odd numbers. The question reads, if A, B, C are three distinct digits, A and C are odd numbers, B is an even number. Which of the following is true? So the options given, B square into AB plus C is odd, ABC plus AC is even, AB plus BC plus CA is odd, 3A square CB minus AC is even. Same again, you have to apply the properties of even and odd numbers. Try to solve this. Okay. So what is given? There are three distinct numbers. So A and C odd number and odd number, and B is an even number. So what is the first option? B square AB plus C. So what is B? That is even square into AB into C. So odd into even. So that is even number plus what is C? That is odd number. So even plus odd will be odd. Even square is again even. So even into odd will be even. So the answer should be even number, but they are saying this is odd. So the first option is incorrect. Next one, ABC plus AC. What is A? Odd into even into C is odd number. Odd into even. So that is an even number. Plus what is AC? Odd into odd. That is nothing but again odd number. Even plus odd is equals to odd number. But they are saying that it is even. So this is also incorrect. Next, AB plus BC plus CA. What is AB? Odd into even. That is even number. Plus BC, odd into even. 2 into 3, 6 again even. Next, AC, that is odd into odd. 3 into 3, 9. So that is odd. So again 2 plus 2 plus 3, 7. That is odd number. So they are saying that AB plus BC plus CA is odd. So the correct answer is option C. So these are the kind of problems that can be asked on the properties of even and odd numbers. So the next concept we will be discussing is prime and composite numbers. So what are prime numbers? These are those numbers which can be divided by 1 and that number itself. So for example, if you take 5, it can be divided by 1 and 5 only, no other number. So what is divided means, if 1 divides 5, the remainder will be 0. If 5 divides 5, the remainder will be 0. So in other words, we can say that the only factors for a prime number is 1 and the number itself. So what is a factor? Factor is nothing but any number that divides another number without leaving any remainder. For example, there is 6. 2 divides 6, 2 3 is a 6, the remainder is 0. So that means 2 is a factor of 6. So 2 is a factor of 6 and 6 is a multiple of 2. So this is concept of factor and multiple. So what is a factor? If any number divides another number without leaving any remainder, then the first number is called as the factor of second number. For example, what are the factors of 8? So 1, 2, 4, 8. So these are all the factors. Now what are the multiples of 8? If you multiply with 1, 8 ones are 8, 8 twos are 16, 8 threes are 24. These are all multiples. These are all factors. So if you take any prime number, it will contain only two factors, that is 1 and that number itself. So that is prime number. They are divisible by 1 and itself. Now the other kind of numbers are composite numbers. These are not prime numbers and they are greater than 1. For example, if you take 6, other than 1 and 6, they have factors like 2 and 3. So these are not prime numbers. So these are composite numbers. Now it is very important to know all the prime numbers from 1 to 100. So you have to by heart those numbers. There are totally 25 prime numbers from 1 to 100, starting with 2 till 97. If you see, so these are the prime numbers from 1 to 100. So the first one is 2, and 2 is the only even prime number. Only even prime. If you see, all other prime numbers are odd numbers only. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So there are total 25 prime numbers from 1 to 100. We should remember all these prime numbers. It will be very useful in solving problems. And 2 is the only even prime number. All other prime numbers except 2 are odd numbers. And what are the composite numbers? They are numbers greater than 1 and also they are not prime numbers. So this is the concept of prime and composite numbers. Now there is another simple concept, co-primes. So what are co-primes? They are set of two numbers or set of three numbers which have only one common factor, that is 1. So if you take any two numbers, like for example 2 and 3, what are the common factors of 2 and 3? That is only 1. Then they are called co-primes. So they can be set of two numbers or set of three numbers or set of four numbers which have common factor only 1. For example, if you take 3 and 7, what is the common factor for 3 and 7? That is only 1. Similarly, if you take 8 and 9, the only common factor is 1. If you take 36 and 25, The only common factor is 1. Then these are all called as co-primes. So these are all called as co-primes. And also the important thing to understand is co-prime numbers can be even or can be odd. So there is no need that co-prime numbers should be prime numbers. Nothing like that. Co-primes can be even or can be odd. But they are set of numbers. That is not a single number and all. They are set of numbers which have only one as their common factor. So even can be odd. 36 is an even. This is an odd. And they are not even prime numbers also. So set of numbers which have only one common factor. They are called co-primes. Next. So try to solve this question. So all the subtopics which come under this topic number system are very important. From every subtopic questions were being asked in the examination. So this is from this prime and composite number. This question was asked in 2023 CSAT paper. So try to understand and try to attempt this question. So the question reads, consider the following in respect of prime number P and composite number C. So there are two numbers. The first one is P, it is a prime number, C is composite number, and they have given three statements. P plus C divided by P minus C can be even. See, in the previous question the word was definitely. So that means definitely, there is no possibility. Here the word can is mentioned. So this can and definitely is very important when it comes to this prelims examination, even in the GS paper 1 or GS paper 2. This can indicates possibility. So please don't forget that. The second statement reads 2P plus C can be odd. So here also again possibility. And PC, so that is PC can be odd. So which of the statements given above are correct? 1, 2 only, 2, 3 only, 1, 3 only, 1, 2 and 3. So try to attempt this question. So this was asked in 2023 paper, very recent one. Okay. See, I will tell you one simple shortcut. Whenever there is word like can, so that indicates possibility. So whenever there is possibility kind of questions, always go with the example based approach. For example, they have mentioned one prime number P, one composite number. For example, take 2 and 6. So P is the prime number for example 2, C is composite number for example 6. So try to substitute those examples in this one. So what is the first statement? P plus C. So that is 2 plus 6, 8. By what is P minus C? That is 2 minus 6 minus 4. So this is again minus 2, which is an even number. So he is saying that possibility, it can be even. Yes, we are getting an even number. So there is possibility. So the first statement is correct. Similarly, what is the second statement? 2P plus C. What is 2P? 2 to is a 4. So 4 plus C, 6. So 4 plus 6 is 10. So 10 is even number. So it can be odd. So they are saying, say always remember when 2P is there, 2P. So that means this must be an even number because you are multiplying with an even number. So when there is C, C can be either even or either odd. So composite numbers, if you take 25, it is a composite number, it can be even or it can be odd. So if you take 26, that is also a composite number and an even number. So if you add even plus odd, that can be odd. If you add even plus even, that will be even. So there is possibility for odd number also, and we are getting even number also. So possibility 2P plus C can be odd. So we are getting that odd possibility. So the statement 2 is also correct. Next one, PC can be odd. PC can be odd. So what is this PC? 2 into 6. That is can be odd they are asking. Now one possibility is P into C, that is 2 into 6 is 12. We are getting even. but they have given is odd. So try to find if there is any odd possibility. So if you take prime numbers, take any odd number, that is 3, and take any composite number which is again odd, because if you multiply it with even number you will get only even number. So take any example for C. For example, 9. 9 is a composite number. 3 nines are 27. So you are getting odd number. So in this option you are getting even number. So there is possibility for odd also. So PC can be odd. Yes, it is correct. So whenever there is this can, the word can possibility, so maximum the statements will be correct, but you have to check once by giving all the possibilities. So the statement 1, 2, 3, all of the statements are correct. So the answer will be D, 1, 2 and 3. So this is the kind of question asked on the concept prime and composite numbers. Okay, let's go to the next question. So again, this question asked in 2020-22 paper. The question reads, consider the following statements in respect of two natural numbers P and Q such that P is a prime number, Q is a composite number. So P is a prime number, Q is a composite number. Again, the first statement, P into Q, P multiplied Q can be an odd number. Again, they have mentioned the word can, that means a possibility. Next, Q by P can be a prime number. P plus Q can be a prime number. Try to solve the question. Same, all the properties of even and odd numbers and the concept of prime and composite numbers, they are all you have to apply. Okay. So what was mentioned in the question? P is a prime number and Q is a composite number. So the first statement reads, P and Q can be an odd number. So can be an odd number means it can be even number, odd number. So again can indicates possibility. So take examples, try to substitute those examples and get the answer. So P and Q. So I will take P and Q, prime numbers. So you have to get odd number. When you get odd number in, when you will get odd number in multiplication, you have to multiply two odd numbers. So P can be 3 and Q can be, for example, any example for Q. So 3 threes are, no, you cannot use 3 again. 2 3 5 7, 3 fours are, so that will be 12. If you take any other number, 3 fives are, so that will be again, so they are asking odd number only, sorry. So if you take prime number 3, composite number 9, you are getting 27, so which is an odd number. So PQ can be an odd number. So there is possibility. So the statement 1 is correct. Take the second statement. What is given? Q by P can be a prime number. So Q by P. So take any composite number such as 9. Take any prime number, that is 3. So what is 9 by 3? 3. 3 is again a prime number. So what they are asking, Q by P can be a prime number. Yes, we are getting. So the second statement is also correct. Next, P plus Q can be a prime number. So third one is P plus Q. So that means you have to add one prime number with another composite number. You should get a prime number. So for example, P is the prime number, for example 2. Take Q as 9. 2 plus 9 is 11. It is a prime number. right? 2, 3, 5, 7, 11, 13. So 11 is a prime number. So third statement is also there is possibility. So it is also correct. So all three statements are correct. So the option D is the answer. So this is how you should use the properties of even and odd numbers and the concepts of prime and composite numbers. Just a minute. So the next important concept in this number system is divisibility. So from this topic also many questions were asked in the previous year papers. So far whatever we have discussed, number system, what is the classification of numbers, the from natural numbers to complex numbers, and then we discussed even and odd numbers and what are the properties of even and odd numbers, and we have solved some problems, and also from previous year's questions we have seen some questions asked using the application based even and odd numbers. Then we discussed this prime and composite numbers, what are prime numbers and what are composite numbers, and also another concept called co-primes. And then we have done some questions on prime and composite numbers. So now we will start with this subtopic, divisibility. So what is divisibility? It is the ability of a number to be divided by another number without leaving any remainder. So for example, if you take the number 6, so if you take any number, for example, you take 6, so divide it with 2, so that means 2 3s are 6, the remainder is 0. So 6 is getting divided with 2 by leaving a remainder 0, so that means we say 2 6 is divisible by 2. So that is simple. What is divisibility? It is the ability of a number to be divided by another number without leaving any remainder. For example, if you take any number 35, if you divide it with 2, so 2 17s are 34, the remainder is 1. So can we say 35 is divisible by 2? No, 35 is not divisible by 2. Why? Because the remainder is not 0. For example, if you take any number 81, if you divide it with 2, 9 nines are 81, the remainder is 0. So that means 81 is divisible by 9. Next. Next, a small this one, that what is division? So we will use some terms. For example, if I am dividing 81 with 9, 9 nines are 81, the remainder is 0, then we are saying 81 is divisible by 9. So you just have to know some terms. So this is called as remainder. So that is nothing but what is remaining after division. So this is called dividend, and this is called divisor, and this is called quotient. So just basics, we have to know this. This is the division process. In this is called divisor, this is called dividend, this is quotient, this is remainder. So simply, if we divide any number with another number, the remainder is 0, then we can say that number is particular divisible by that number. So here 81 is divisible by 9. Now if I give you a number, for example, very big number 4 5 7 9 8 2 3, I will ask you, tell me whether this number is divisible by 2 or not. So every single time you cannot do this process, right? So that will be time consuming. So for that purpose only, there are things called as divisibility rules. So we will discuss divisibility rules next. Now the first one is divisibility rule of 2, 4, 8 and 16. So if I give you any number, but suppose there is a number of 6 or 7 digits. So if I ask you whether that number is divisible by 4 or not, whether that number is divisible by 8 or not. So there are some particular rules, divisibility rules you have to apply. So in order to know whether that number is divisible by these numbers. Now why I have combined the divisibility rules of 2, 4, 8, 16 at one place is because these divisibility rules are almost similar in approach. So all these numbers divisibility rules are almost similar. So one by one we will see. So the first one is divisibility rule of 2. So what is the divisibility rule of 2? If there is any number whose unit digit is even number. For example, if you take 1, 2, 5, 6, 7, 8. If the unit digit is an even number, then that number is divisible by 2. So if you divisible by 2, if you divide this number by 2, the remainder you will get is 0. So what is the divisibility rule of 2? The unit digit should be even number. If the unit digit is odd number, that number cannot be divisible by 2. For example, if you take example like 5, 8, 9, the unit digit is odd number. So if you divide that number with 2, the remainder will not be 0. So this is the divisibility rule of 2. Very simple. Next, the divisibility rule of 4. If the last two digits of a particular number is divisible by 4, then the whole number will be divisible by 4. For example, if you take 4, 5, 9, 3, 2, 4. So you have to take the last two digits. If the last two digits is divisible by 4, 4 6 are 24, the remainder is 0, then the whole number is divisible by 4. So what is the divisibility rule? Last two digits must be divisible by 4. Then the whole number is divisible by 4. If you take a number like 431531. So if I ask you whether this number is divisible by 4 or not, check the last two digits, 31, whether it is divisible by this one or not. So 4 sevens are 28, remainder is 3, remainder is not 0. So this number is not divisible by 4. Next, the divisibility rule of 8. Again, if I give you a particular number, check the last three digits of that number. For example, 1, 2, 3, 4, 5, 8, 00. This is the number. To check whether the number is divisible by 8 or not, consider the last three digits. What are the last three digits here? 800. Check whether the three digit is divisible by 8 or not. Yes, 8 into 100 is equals to 800. So the whole number is divisible by 8. So what is the rule? Last three digits must be divisible by 8. Then the whole number is divisible by 8. If you take like 1, 2, 3, 5, 1, 1, 1, whether this number is divisible by 8, if you take 1, 1, 1, it is not divisible by 8. So the whole number is not divisible by 8. So if you understand the pattern, it is all similar. So that's why we grouped 2, 4, 8, 16 at one place. Similarly, if you take the divisibility rule of 4, it is nothing but last four digits must be divisible by 4. Then the whole number will be divisible by 4. For example, if you take 1, 5, 6 and 3, 16, 32. So I will ask you whether this number is divisible by 16 or not. So take the last four digits, whether it is divisible by 16 or not. So 16 ones are 0, 16 twos are, that is divisible by 16. So what are the rules for 2, 4, 8, 16? For 2, take the unit digit, whether it is divisible by 2 or not. That means if the unit digit is even number, that number is divisible by 2. If it is an odd number, it is not divisible by 2. What is the divisibility rule of 4? Take the last 2 digits. Check whether those 2 digits are divisible by 4 or not. If it is divisible, the whole number is divisible by 4. Next, what is the divisibility rule of 8? Take the last 3 digits. Check whether those last 3 digits are divisible by 8 or not. Next, what is the divisibility rule of 16? Take the last 4 digits. Check whether those 4 digits are divisible by 4 or not. So these are the divisibility rules for 2, 4, 8, 16. Also, you can understand one pattern here, that is 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16. So if you see, to check whether a number is divisible by 2 or not, you have to check for the unit digit. If you want to check whether the number is divisible by 4 or not, you have to take the last 2 digits. If you want to check whether the divisible or not by 8, then you have to consider the last 3 digits. If you want to check with 16, you have to consider the last 4 digits. So in this way also you can remember the divisibility rules of 2, 4, 8, 16. Now let's try to solve some problems on these divisibility rules of 2, 4, 8, 16. So this question was asked in CSAT paper 2020. So the question reads, how many integers are there between 1 and 100 which have 4 as a digit but are not divisible by 4? So try to understand and solve this question. Every single subtopic from the number system is very important for the exam. And in yesterday lecture, I have shown you the PYQ trend analysis. The maths is around 50% of CSAT paper on an average. Even for the past 4 years, the maths constitutes around 50%. In that, almost 40 to 50% of questions are from the number system. So from all these topics, even from the even odd numbers, prime composite numbers, divisibility rules, LCM, HCF, all these topics of number system are very important. So almost 25% of the question paper you can try to attempt if you practice this topic very well. Okay, let's try to solve this. How many integers are there between 1 to 100 which have 4 as a digit? So what are the numbers that have 4 as a digit between 1 to 100? If you take single digits, that is 4. If you take 2-digit numbers, that is 14, 24, 34. But if you see that series of 40 to 49, all have 4 as a digit. So let's try to write those: 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Okay. Next, what are the numbers that have 4 as a digit? 54, 64, 74, 84, 94. So these are the integers between 1 to 100 which have 4 as a digit. So total count, how many integers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are total 19 numbers which have 4 as a digit. Now they are asking how many of them are not divisible by 4. So first check how many numbers are divisible by 4. For example, 4 is divisible, 14 is not, 24 is divisible, 14 is not, and 40 is divisible, 44 is divisible, and 48 is divisible, and 64 is also divisible, 4 16s, and 84 is also divisible. So now count how many numbers are divisible by 4. 1, 2, 3, 4, 5, 6, 7. Now they are asking how many are not divisible. So just subtract from the total how many are divisible. 19 minus 7. So that is 12. So the answer is option C. So this is how they are asking questions on the divisibility of 4 and all. How many numbers between 1 and 100 which are not divisible by 4 and have the digit 4. So these are the total, there are 19 numbers which have 4 as a digit, and in those digits only 7 are divisible. They are asking which are not divisible. So 19 minus 7, 12 is the answer. Now see the next question. So the question reads, if 653xy, this number is divisible by 80, what is the value of x plus y? So you just have to use the divisibility rules in order to solve these kind of questions. Take time, try to solve. These are very easy questions. You should not take much time to solve these kind of questions. Okay, let's try to solve it. So the number given is 653xy. So this is a number which is divisible by 80. Now you may ask me, sir, you taught us only the divisibility rule of 8, but the question is being asked on 80. So no need to panic. If a particular number is divisible by 80, which can be written as 8 into 10, then that number will be divisible by both 8 and 10. So this is one of the property in divisibility. So we will discuss it later. So for example, if you see 6 is a number and 36 is divisible by 6. Now 6 can be written as 2 into 3. If you see 36 is also divisible by 2, 36 is also divisible by 3. So this is only if any number which can be expressed in the product of any two numbers, those two numbers also will divide that number. So 80 which can be expressed as 8 into 10. So if this number 653xy that is divisible by 80, that means it is divisible by both 8 and 10. Now just understand, if any particular number which is to be divisible by 10, it will have 0 as unit digit. 10 ones are 10, 10 twos are 20, 10 threes are 30, 40, 50, 60, 100, 120. So take any multiple of 10, it will have 0 as the unit digit. So that means this number is divisible by 10. That means the unit digit must be 0. So what is the value of y? 0. Now 653x0 is divisible by 10. Now the remaining number must be divisible by 8. So what is the remaining number? 653x. It is divisible by 8. Okay. Now what is the divisibility rule of 8? 5 3x. you have to consider the last 3 digits that should be divisible by 8. Now 53x. What are all the possibilities? For example, 530, 531, 532, 534 and up to 539. So check whether that is divisible by 8 or not. Is it divisible by 8? So 8 ones are and 8 6 are 48. So 8 6 are 48. So 48 and 50 we are getting. So that is not divisible. So here we will get 51 not divisible, 52 not divisible, 54. One minute. So this number 53, 8, 8 6 are 48 and 5 and x. So 54. So 534 is divisible by 8. Understood? So what is the answer? What is the value of x? That is 4. So x is 4, y is 0. What is the value of x plus y? That is 4. So the answer is C. So here the thing we have to remember is, if a particular number is divided by 80, divisible by 80, that means it can be expressed as 8 into 10. The number will be divisible by both 8 and 10. For any number to be divisible by 10, the unit digit must be 0. So here the value of y is 0. Then you have to check the possibilities for the other number, that is 653x divisible by 8 or not. For that you have to take last 3 digits 53x, and you can check for all the combination, that is 534 is divisible by 8. So the value of x is 4, y is 0, and the answer is x plus y 4. Next we will discuss divisibility rule for 3 and 9. Again, these two numbers have similar kind of divisibility rules. The first one is divisibility rule for 3. What is the divisibility rule for 3? If you take any particular number, take the sum of all the digits in that number. If that sum is divisible by 3, the whole number is divisible by 3. For example, 1, 2 and 3. This is one number. You have to check whether that number is divisible by 3 or not. Take the sum of all digits. 1 plus 2 plus 3. So that is nothing but 6. 6 is divisible by 3. 3 2s are 6, the remainder is 0. So the whole number is divisible by 3. For example, if you take 7, 3, 4. So take the sum. So what is the sum? 7 plus 3 plus 4 is 14. But 14 is not divisible by 0. So that means remainder is not 0. So this particular number is not divisible by 3. So like that, if you given any number, even if it is of 10 digit, 11 digit, you have to take the sum of all the digits in that number. If that sum is divisible by 3, then that number is divisible by 3. Next, similarly, the divisibility rule of 9 is also same. Take sum of all the digits in that number. If that sum is divisible by 9, the number is divisible by 9. So for example, take the same number 1, 2, 3. What is the sum? 6. It is not divisible by 9. So it's not divisible. If you take any number like 1, 3, 5, 9. 1359 is a number. You have to check whether that number is divisible by 9 or not. So what is the sum of all the digits? 1 plus 3 plus 5 plus 9. 1, 3, 4, 4, 5, 9, 9, 9, 18. So 18 is divisible by 9. 9 2s are 18. The remainder is 0. So that means this number is divisible by 9. So these are the divisibility rules for 3 and 9. So if you write it, what is that? Sum of digits. Sum of all the digits must be divisible by 3, then that number is divisible by 3. Again for 9, sum of all digits must be divisible by 9, then that number is divisible by 9. Now let's try to solve some questions on the divisibility rules of 3 and 9. So try to solve this question. The question reads, if 381a is divisible by 9, find the value of the smallest natural number a. Okay. So what is the given number? 381a. This number we should check whether it is they are saying that the number is divisible by 9. So that means sum of all the digits of that number is divisible by 9. So what is the sum? 3 plus 8 plus 1 plus a. So that is nothing but 3, 8, 12. 1 minute. 3, 8, 11, 12 plus a. So 12 plus a. And you have to check whether that number, whether that sum is divisible by 9 or not. So what is the smallest natural number for a? So if you take 0, 12 plus 0 is not divisible by 9. Next, if you take 1, it's not divisible. If you take 2, 12 plus 2, 14, not divisible. 3, 12 plus 3, 15, not divisible. 4, 16, not divisible. 12 plus 5, 17, not divisible. 12 plus 6, that is 18 by 9. So that is remainder is 0. 9 to the 18. So what is the smallest possible number for A? That is 6. So this is how you will use the divisibility rule to solve the sum. Okay, let's see the next question. Again, this question was asked in the 2019 CSAT paper. So the question reads, there is an 8-digit number 4252746b. It leaves a remainder 0 when divided by 3. So what does it mean? If you are dividing that number with 3, the remainder is 0, means that particular 8-digit number is divisible by 3. Now how many values of b are possible? Similar to the previous question. So here they are asking what are the number of possible values for b. So use the divisibility rule of 3. Try to solve the question. Very simple question, very similar to the previous question that we solved. Okay, let's try to solve it. So there is an 8-digit number. This is that 4252746b. Okay, so this number is divisible by 3. So when it is divisible by 3, when sum of all the digits is divisible by 3. So what is the sum? That is 4 plus 2 plus 5 plus 2 plus 7 plus 4 plus 6 plus b. So 4, 2, 6, 6, 5, 11, 13, 20, 24, 30. So the sum is 30 plus b. Now this sum should be divisible by 3. Now what are all the possible values? So if you give 0, 30 plus 0. Yes, it is divisible by 3. Next, if you give 1 not divisible, 2, 32 not divisible, 3. If you give 3, 33 is divisible. Next, if you give 6, 36 is divisible. If you give 9, 36 is divisible. So you can take only the digits from 0 to 9. So for all these values, that particular sum is divisible by 3. That means that whole 8-digit number is divisible by 3. So what are the possible number of values? 4. So the answer is 4. So these are very simple questions from the number system. Now, one more. The question was asked in CSAT 2019 paper. Again, the divisibility rule for 3. So the question reads, number 136 is added to 5b7 and the sum obtained is 7a3, which is exactly divisible by 3. The only possible value of b is. So 4 options given. This is also very simple one. The possibility based question that we did earlier. So try to solve this, take time. So these are very easy, simple and low hanging fruits kind of questions. You should not miss. So you have to get the answer right. Try to solve. Okay, let's try this one. So number 136 is added to 5b7. The sum is 7a3 and this 7a3 is divisible by 3. So what is given? 136 is added to 5b7. The sum is 7a3. And they are saying that 7a3 is divisible by 3. So that means sum of the digits of 7a3 is divisible by 3. So what is the sum? 7 plus a plus 3. So that is 10 plus a. This is divisible by 3. So what are the possible values for this one? So if you give, what are the possible values for a? So if you put 0, 10 is not divisible, 1 not divisible, 2, 10 plus 2, 12 is divisible by 3. If you put 3, 13, 4, 14, 5, 15, yes, 5 is a possibility, 15 is divisible by 3. If you put 6, 10 plus 6, 16, not possible. So again, if you put 8, 10 plus 8, 18, 18 is divisible by 3, 18, 3, 6 is 18. So what are all the possible values for a? That is 2, 5 and 8. Now try to bring those values here. If a is 2, for example 136, and if a is 2, five b7. So I am taking 7a3, that means 7, 2, 3. So what are the possibilities? See, if you add 6 plus 7, 3, 1 is carried, 6 plus 7, 13, 1 is carried, 1, 3, 4, 4 plus b is 2. So what number, if you add it to 4, you will get 2. So that means b should be 8. Okay. So 1 plus 3 plus 8 is 12. Again 1 is carried out. 1 plus 1 plus 5 is 7. So 2 is possible. So what is the possible value for 2 is 2. So if you try with the other also, 136, 5b7 and 7a3. I am taking the value for a as 5. So 7, 5, 3. So try to see whether this is correct or not. 6 plus 7, 13. 3 is here, 1 is carried. 1 plus 3, 4. And you have to get 5. So 1 plus 3, 4. That means b value should be 1. So 1 plus 3 plus 1 is 5. But 1 plus 5 is 6. Here it is given 7. So there is no possibility for 5. So similarly, check for 136, 5b7 and 7a3. That means 783. Again 6 plus 7, 13. 1 is carried. 1 plus 3, 4. And you have to get 8. So that means b value should be 4. Now 1 plus 5 should be 6. Here it is given 7. So that means this is also not possible. So what is the only possible value for A? That is 2. So if you are putting 2, what is the value of B? That is you are getting 8. Sorry. So they are asking the only possible value of B. So if you are putting 2 in the place of A, what is the value you are getting for B? That is 8. So the answer is 8. So this is how you should apply the divisibility rules. The next one is divisibility rule of 11. If you take any particular number, you have to divide that number into odd places and even places. So that means whichever digits are located in the odd number positions, they are odd places, and even number positions, that is even places. The sum of odd places minus sum of even places, if that is divisible by 11, that number is divisible by 11. For example, if you take any number, for example 1 2 3 1, so this is a number. This is the first position. You can take it from any side, either right side or left side. So this is the first position, that is odd position. This is the third position, odd position, odd. And this is the even position and even position. So the rule is sum of odd places minus sum of even places. If this thing is divisible by 11, the whole number is divisible by 11. For example, what is the sum of the odd places? 1 plus 3 is 4. Minus what is the sum of even places? That is 2 plus 1, that is 3. That is 1. So if 1 is divided by 11, it is not divisible. So this number is not divisible by 11. For example, take a number 209. 3-digit number. So if you take 1, 3. So these are the odd places. This is the even places. What is the sum of odd places? 2 plus 9, 11 minus what is the sum of even places? That is 0. That is divisible by 11. So 11 ones are 1. So this number 209 is divisible by 11. Understood? So this is the divisibility rule for 11. So let's try to solve some examples based on the divisibility rule of 11. See this question, again similar to the question that we solved earlier. If A381 is divisible by 11, find the value of the smallest natural number for A. Very easy question. You have to solve it. Okay, let's try to solve this. The number is A381. it is divisible by 11. What is the smallest number for A? So the number is A381. As I told you, what is the divisibility rule for 11? Sum of odd places minus sum of even places, that should be divisible by 11. So if you take, this is the first position, this is the third position. So these are the odd positions, these are the even positions. So what is the sum of odd positions? That is A plus 8 minus, what is the even positions? 3 plus 1. That is nothing but A plus 8 minus 4. This is A plus 4. Now you have to check it is divisible by 11 or not. So what are the possible values you can add here? Which is the minimum value? Then it will be divisible by 11. So that means 7. 7 plus 4 is 11. Na? So 11 is divisible by 11. So the smallest number for A is 7. That is option C. So this is how you apply the divisibility rule of 11. Let's try to solve the next question on the divisibility rule for 11. So the next question, the question reads, a number in the form of 10 to the power n minus 1. So the number is in the form of 10 to the power n minus 1 is always divisible by 11 for every n being a natural number. When? So the options is, if the n is odd, if the n is prime, if the n is even, can't say. So you have to apply the divisibility rule of 11, or else you can use any other trick. So try to solve the question, take time, try to solve. Okay, let's try to solve this. So what is the number given? 10 to the power n minus 1. They are saying that it is divisible by 11. So what are the possibilities for n? Whether n is odd number, prime number, even number, or can't say. So in these kind of problems, the simple trick is to try to put some values. So if you take the first option, go through the options. So the first option is, if n is an odd number, for example, if you take 1, if you take n is equals to 1, so what will be 10 minus 1 by 11? So that is 9 by 11, that is not divisible by 11. So n is odd number is incorrect. So take the next option. They are saying that n is a prime number. For example, take n 3. So 10 cube minus 1 by 11. So 1000 minus 1, 999 by 11. So again, 9s and 9. This is not divisible by 11. The remainder is you are getting 9. So this is also incorrect. If you see the third option, n is even. For example, take 2. So 10 square minus 1 by 11. So 100 minus 1, 99 by 11. Yes, 11 nines are 99. The remainder is 0. So n can be even. So this option is correct. So in these kind of problems, no need to panic. Try to substitute some values, and also you can go through the options. So the answer is C. So with this we have completed for the divisibility rule 11. So try to practice, try to revise whatever have been discussed in the class. In tomorrow's class we will continue with the number system again. Thank you.